there's the very simple page where you can go to initiate your crowd sale or create your ETF. You don't have to initiate a crowd sale. There's many different things you can do with it. Yeah, let's actually really quickly go, because I don't want to take too much time from our Q&A, and actually create a currency in real time right now on Ethereum's testnet. All right, so it brings up the bot. You can use Telegram, you can use Facebook. We're integrating now with WeChat. We also have some other integrations that are unannounced, but we will talk about them more shortly. Eyal is here, is really quickly just going through the questions, answering them. What's the name of your currency? What's the name in, the plural name of it? What's your location? All right, so it knows we're in Amsterdam. What do you want your symbol to be? This is testnet, right? So we can just play around with it and do whatever we want. All right, now he goes to sign his transaction. Takes about, 13 seconds or so to process a block, so it's going to take a few seconds till it's done. But here's our currency already for Bitcoin Wednesdays. If somebody wants to go on to Parity or check it out, you can find it already on the testnet. We'll just maybe add a nice little photo for Bitcoin Wednesdays. Okay, we can't find it right now, but you can see how easy it is. Anybody can then now kind of set their group. You can have discussions in this group. Oh, there it is. That's the ping we just got back from testnet. That just tells us that the token was successfully created. And that's it. Thank you. Eyal, if you can come up, I promise to let you do the Q&A.
Yeah, that's well, we're just making history right here with the first live demo, and I think it's very interesting. You were mentioning the learnings you were taking from myopia, which you would think is completely different, and applying it here. If you were to talk about I guess that has also allowed you to look at it a little bit differently than. And really more from a community perspective, right? What are the key things that kind of, I guess I'd be very interested in kind of the first eye-opening steps you went through there.
So I think what was different for Guy and myself when we saw Bitcoin for the first time in 2011. This was after we did a lot of research into economics and how money works and how money issued and how banks are working. And we were actually quite amazed to learn how the system works. And when we saw Bitcoin, and given our background in consumer technologies, what we saw is essentially the first user-generated currency that is actually traded across the world, and no one even know who is the user who generated it, but it works. And when we saw that, we started to think about, there's going to be many, many more from, I would say, economic perspective, because when thinking about this, every stock of every company is a currency. Every bond is a currency. Every derivative is a currency. It's just different currencies that have different properties, different behaviors. And at that moment, we thought, what should be the platform, the economic basis that can work with all those currencies and connect them together? And we didn't have a really good answer for that until Ethereum came up. So we were experimenting a lot in the years 2013, 14 with user-generated currencies that we created on a non-blockchain platform that we created just to see how people use community currency. We created the first, I would say, community currency platform that had more than 1,000 transactions a day by people buying products and services from each other using a currency that they created. So we wanted to experience the user side of it. We were less interested in trading Bitcoin or all those custom solutions. We were looking, because every revolution that you can think of technologically always comes from the end user. It's the Facebooks, the WhatsApp, the YouTubes that bring on the revolution. It never comes from the top. It always comes from the bottom. So we were searching, and we're still searching for that end user experience that can drive this revolution.
Okay, thank you. Question?
There was one word that tricked my attention. You said when you send a token to the contract, you get the other user-generated token issued. Do you mean with issuance creation, or do you mean with issuance actually buying?
So the way that it works is that we have this concept, we call it Bancor compatible token. A Bancor compatible token is a token that first can hold one or more other token in the reserve, and second is issuing itself in exchange for any of those reserve tokens, and releases the reserve in exchange for its own token. So imagine a smart contract that you can buy the currency from the smart contract whenever you want. Now, whenever you buy the token from the smart contract and you pay, let's say with Ether, let's say the reserve is in Ether, and you pay Ether and you get the token, and whenever you do that, the price actually goes up. And whenever you are doing the opposite, which means that you liquidate your token and you're turning back to Ether, the conversion price goes down. This means that the price is constantly adjusted toward the price point in which there is equilibrium between the volume of the buying and the volume of the selling, which we believe is the right price for the token. And this is actually how it happens in exchanges, but on a synchronous mode, where here there's what we call asynchronous price discovery mechanism, where you can have a token that every day just one person buy or sell it, and it's not a problem because they don't need to be matched with each other, and the price is determined over time.
It's not just for
compatible token. The token itself is its own market maker, which is something that can only be done in the age of smart contracts.
Could you explain what the role of Bancor itself is? I mean, the token Bancor, because I don't see the necessity.
Good, great question. The idea of Bancor token is that we can, you can compare it to Ethereum smart contracts and Bitcoin smart contracts using RSK. So RSK is essentially using Bitcoin as the currency for smart contracts, while Ethereum has its own currency. Now, because it has its own Ether currency, it actually create value according to the success of the platform of Ethereum. So when there's a currency like Bancor that we are going to offer as the default reserve currency for any currency created on our platform, the meaning of that is that as more and more currencies are created using Bancor as a reserve, it would increase the demand for the Bancor currency and actually create a network out of all those tokens. So they actually can benefit from the network effect. So if one currency succeeds and the value of the Bancor currency goes up, everyone benefits. In the same way that if one application on Ethereum is doing well and it increases the demand for Ether, everyone that works with Ether benefits from the value increase. So it's actually a way to create a network effect between all the currencies that use Bancor as their reserve token.
I like to even think about it that Bancor is essentially, the currency, is essentially encapsulating the network effect of all the currencies that are built on top of it.
I've got many questions, but I don't want to monopolize the discussion. So.
And by the way, there's a lot of new stuff in this concept, and we're very used to it. There's a lot of questions, and the more people have a background in trading, and the more people are kind of like, hardcore finance folks, they tend to have many questions. And so I encourage the people with kind of deep questions to, first of all, go to our website, bancor.network, download our white paper, read it. We're working on ways to make the white paper a little bit more easy to digest, because it's a lot of concepts to pass. And then, of course, if you still have questions, reach out to us. We're going to be doing lots of Reddit Ask Me Anythings, and we're going to be all over the world, like we've been recently in China and all over Europe. And so we're happy to follow up with anybody.
So you guys mentioned how smart contracts and, therefore the removal of need for a human middleman means that we have this ability to create trustless, everything, governments, currencies, everything, companies, everything. Therefore, is your code and your algorithm, like Golems, for example, open sourced?
Yes, you can actually go to the website right now and look at the smart contracts and download them, review them.
And the entire thing will remain open sourced forever.
Yeah. Yes, of course. I think that the beautiful thing about this new asset class and this new way of raising seed funding with a token, I think the most beautiful thing about it is that it's really supportive of the idea of open source, because the common interest of the group is just to get the token to be as popular as possible, like in Bitcoin. It's the common interest of everyone to use Bitcoin and get as many people to use Bitcoin, because people are profiting from the value of Bitcoin that appreciate. They are not profiting from the margins that they're able to make because they have a closed source that put you ads that you don't want to see. So I think we're talking about a much novel, more novel model, a more modern novel model that is more efficient, because open source means that people can cooperate with each other, and we don't need to see the same a piece of software developed by 20 teams at the same time competing with each other. We have what I call the option to hard fork. If there's a project and you think that it can be done much better, you can fork it and you can take it from there. I think this is much more efficient, and this is how evolution works and got us to here. So how bad it can be.
This is one of the reasons we set up Bancor as a nonprofit foundation, because our goal is to create a standard, and we wanted to be very clear about that. And then, just one more thing to touch upon what Eyal said. I think that the real first killer use of kind of these tokens that you see projects like Golem and others issuing is that for the first time it gives a business model to open source services. And this was just not possible in the past. But if you think about it, Facebook and all these things we do on the internet, these are all services. And they're going to have a very, very hard time competing in a world of open source services. But until we had this token revolution, I mean, it really wasn't possible to do that.
Okay, we'll do last question, and actually after this question, we'll take a short break, because we were told next door we'll get busy later on. So even though we're only 2/5 of our way into the program, we'll take a quick 5-minute break now before it gets too busy next door. Yeah, but a quick last question.
Hi. Your stated goal was to provide more liquidity, as far as I understand it, and you were using. It sounds like a bit of a pig that the price of the token issued would be based on the underlying assets sent to the smart contract. Is that correct?
No, that's actually a common misconception. The value of the token is derived only from its utility. So the reason that Golem token worth anything is because people believe that they will have a utility in the Golem network. So the price of Bancor token is not different. It's not derived by the reserve. The reserve is only a feature. It's a function that is provided to anyone that does a price discovery and provide liquidity in an asynchronous way. But the price is driven by how many people want to buy the token. Well, in comparison to how many want to liquidate it, and if more people are selling it than buying it, then the price will drop, to zero. If more people are buying it than selling it, the price will go up. But this is not the source of value of the token. That's a very important point.
Okay, so if that's the case, wouldn't you end up in a situation where you wouldn't have enough reserves in the smart contract if the price is floating?
So the fancy formulas that were here showing up before, I'll tell you a story. It took me like a week in Excel to look for those formula, to find this formula, in order to make sure that what you're saying will never happen. Okay. Because the formula is keeping what we call a constant reserve ratio, meaning that if you have a reserve of Ether, and let's say you have 10 ether in the reserve and the constant reserve ratio is 20%, it means that the price calculated for your currency right now is exactly 50 ether, because it's 20% of 10 ether, then the market cap of all your token will be 50 ether. And whenever someone is buying, it means that the reserve grows up. You have more reserve. Then therefore, if you calculate the price per unit, you will see that the price goes up per unit. Whenever someone is liquidating, then it means that ether is coming out of the reserve balance goes down, and then the calculator price is actually lower. We call that concept CRR. You can read about it in our in our white paper. And the reason that those formula lists seems a little complicated is because what they are making sure that if you buy or sell a lot of currency, it would act as if you are selling infinite parts in infinite amounts, small amounts, and the price is recalculated after each sale. So every time that you're buying or selling, it's like infinite number of buying and selling, and after every small particle, the price is recalculated in order to make sure that the reserve is whatever it was set, the CRR, which is 20% or 10% or whatever percent you
I'll
want.
definitely have to look a bit closer at that. But if the liquidity is based on the underlying assets, wouldn't that also act as a limit on the liquidity of the token you're
So this is important. There's always a limit on the liquidity. For example, if I want to sell 20% of the supply of bitcoins right now, even Bitcoin that is very liquid, I cannot sell 20%, and I will drive the price basically to zero if I try to do that. So liquidity is always limited at some capacity, but we believe that what we are offering is offering much less volatility than what's experienced today in the exchange.
because it would be a basket, right? That's why you'd have
No,
more
not
liquidity.
because it's a basket, but because when you have, for example, 10% CRR, which is not much, it's 10% that you hold in the reserve, it means that it's almost, you can compare it to an exchange that right now in the market depth, there is 10% of the supply in the market depth waiting for you to buy or sell. So in terms of the volatility, we expect way smaller volatility than what experienced. It's not perfect liquidity, but to the exchanges are not providing perfect liquidity.
10% liquidity for the underlying assets for the token?
What I'm saying is
Right.
that it would be like having a market depth
Okay.
in the size of the 10% of the total supply of the currency. That's a huge market. I've never
Understand.
seen one that big. And the market depth is what defines the level of liquidity that you currently have. Because if there's very shallow depth, there's very little liquidity. If there's deep depth,
I suppose if the reverse the reserves run out, then the price of the underlying token would then go down.
it can never run out. The way that the formula works is the reserve will always be worth exactly X% of the market cap as defined. And again, you can read.
It's quite complicated. I'll have to look into this more. It's very interesting.
Great. I'll be happy to talk more about it.
Sounds like it's going to be an interesting white paper. Yeah. So okay. So yeah, as we were told, the best time to take a break is a bit early before it gets too busy next door. We'll take a quick 5-minute break. Please keep it short because we have still 3 more speakers this evening. Yep. Thank you. Okay, can we get everybody to take a seat? We have still some people out in the hallway. Can we maybe wave them in? Do we have people coming in the door still? A few people? Okay, we'll let you file in. It's a little tight coming in and out. No, there is one, but I don't know it. Yeah. Okay. Hopefully everybody managed to get some refreshment. Get your wired up, Jeff? Okay. All right. We're very excited to have Jeff Garzik. He flew in just for this from Atlanta, and I understand you're already off back to Boston tomorrow. So also big thanks for the personal effort and strain of coming out and all the travel, just for sharing your thoughts with us. I think many of you know Jeff. He has been involved in Bitcoin very early on already, early contributor. Back in 2010 was when you got started, correct? July 2010, contributing on development. Also 10 years at Red Hat, which has been, I think, also some of the foundational experience that led you to create Bloq. And Jeff is the CEO of Bloq, and working with mainly large financial institutions at implementation and commercialization of the technology, and in particular also allowing for the use of Bitcoin also in private networks, which I think there are a lot of areas that we would love to hear from Jeff about today. But I understand today you're actually going to talk about one of the biggest issues that everybody's discussing, which is the future of Bitcoin itself. So with that, excited to have you join us, and look forward to what you have to share with us. Jeff, thanks.
Thanks for...
You can also take that microphone.
Check, check, check. Okay. Secondary mic doesn't seem to be working. Hello. Thank you all for having me. This is a fantastic group. It's a packed house, and I'm deeply honored that you allow me to speak. I'm Jeff Garzik. I'm the CEO and co-founder of Bloq, but I've been a Bitcoin core developer, now that I'm building a company, for several years. So I thought I'd bring some insights and thoughts on some of the current Bitcoin controversies, speak about those today. Next slide, please. So a little bit about my company, just to get in a quick plug, is we're, I like to say, very similar to a Red Hat of Bitcoin. If you need monthly support, enterprises tend to not download it yourself from GitHub. They don't like depending on volunteer developers for multi-million-dollar financial systems. So for those larger enterprises, larger businesses, we have our product Bloq Enterprise. That's I'll give you the secret decoder ring for our products. Anytime you see the word blockchain, underneath it's really Bitcoin. But you know, we're riding the blockchain wave, the blockchain hype. But that is our stack. That's a Bitcoin stack. We have nodes, wallets, smart contract engines, etc. All of that is very relevant in this space for large enterprises. And then second, for consulting, in addition, we also do blockchain and Bitcoin consulting as well. So for large enterprises, this is really bringing Bitcoin to the large enterprise, taking it out of sort of the volunteer developer space and maturing the software, hardening it, securing it, etc. Next slide, please. But I'd like to talk about Bitcoin. I think we're really at a decision point right now. There are several proposals for how to upgrade Bitcoin, but Bitcoin governance itself is a very, very tricky, very difficult topic. You can't just upgrade software and magically it works. In Bitcoin, the thing known as consensus rules, that's really like the constitution for Bitcoin. Everyone has to follow these consensus rules. Otherwise, your transactions are considered invalid. They don't go out on the network. And so that's what I mean by the consensus rules are really the constitution of Bitcoin. Is if you follow that, you're on the network. If you don't, you're not. It's that simple. So what is my approach? My point of view is really it's user-centric. What is that user experience? You know, let's not talk about theory. Let's not talk about what's going to happen 12, 24 months from now. Let's talk about what is the user experience, what is the impact on users with each of these changes. And there's a fancy name for listing the pros and cons of a particular option, whether that's, you know, the pros and cons of a house you're buying or a car you're buying, or in this case, the Bitcoin upgrade. That's called the Kepler-Trago method. And it's, you know, a Fortune 500 fancy term for listing the pros and cons of an approach. So we get our data points, we list the advantages, disadvantages, and then after that analysis, you say, what are the best methods to upgrade Bitcoin? Field experience, this was one of the lessons from Red Hat and Linux, is that field experience matters the most. Everyone has a theory about, I want to change the software to do this, or theoretically, this upgrade will have this effect. What I learned from 15 plus years in the Linux community is that, excuse my language, engineers talk a lot of bullshit. And at the end of the day, the only thing that matters is what's deployed in the field, what's working in the field, how it's working in the field. Field data trumps everything else. Next slide, please. This is really the technology landscape that I think we're at today. We started with the PC, the worldwide village of the internet. Of course, the internet only exists because we have a single common language to talk with each other. That's the TCP/IP protocol. Every mobile device, every computer can talk to every other computer only because they speak this common language, TCP/IP. The mobile, put that supercomputer in your pocket. We started with social era with collaboration and networks. And now finally, we're in the blockchain era. And I very specifically put the Bitcoin protocol up there. I think that the Bitcoin protocol is currently the most successful, the most secure, and so therefore has the highest likelihood of being successful in the future, being that TCP/IP of value. Next slide, please. So this is some of the examples of what are the piece parts of the Bitcoin community. We have the consensus rules. That's really our constitution. We have the ledger itself. That's the register of assets, as I like to call it. What public key owns what Bitcoin? What public key controls which Bitcoin? Bitcoin the protocol, Bitcoin the currency. Those are obviously two different things. And the core developers, they're the people that are generating this innovation. As mentioned, I was a core developer on Bitcoin for many years, so I'm very familiar with this. The miners, they are the people who run computers that secure the Bitcoin network. And then we're starting to see some new innovations such as side chains, which are they're not altcoins. These are pegged to Bitcoin chains, which have additional features added. Blockstream, a well-known company, they're working on side chains. My company, Bloq, is working on side chains. This is complementary to some of the other new features like the Lightning Network. Next slide, please. So this is really where we are today. Bitcoin is a global, decentralized, leaderless network. Now think about governance. How do we upgrade a leaderless network? That is the paradoxical question of the day. How do we govern the ungovernable? How do we lead the leaderless? And I'll present some examples, primarily in terms of terminology. Fork is what engineers use to describe essentially a software upgrade. But it's a special kind of software upgrade because everyone has to come to consensus all over the world on what that next version of the Constitution is. Next slide, please. So consensus rules, they're really the Constitution. Each one of these features is coded into the Bitcoin software itself. And the analogy I like to draw is if two people are on opposite sides of the earth, I give them each the same math problem, 1 + 1. They will arrive at the same result, 1 + 1 = 2, without communicating with each other. That's the key to how Bitcoin works. That's called determinism, is that if you're given the same inputs, without communication between multiple parties, you will have the same end result of that math problem. That is how Bitcoin manages to function in a leaderless fashion. Every single computer, every single node running Bitcoin, they don't communicate with other computers and say, okay, I trust your answer here on who owns which Bitcoin. It's a trustless network and trustless algorithm. And that depends on, again, everyone executing these same consensus rules in the same order, in the same way, and arriving at the same result independently without communication between each other. So that's a difficult concept to grasp, but that is the fundamental nature of how Bitcoin and blockchains function, is you each execute the same evaluation in the same order. You're guaranteed to achieve the same result, which is, Jeff owns 0.5 Bitcoins, or Rick owns 4,000 Bitcoins and he's incredibly rich. So it's basically that determinism is how the consensus rules impact Bitcoin. Next slide, please. So one of the things that I like to describe here is the way that miners work. Miners are, another word for those are transaction validators. And transaction validators are nodes on the Bitcoin network, which they examine incoming transactions that send Bitcoins between two people, and they evaluate against those consensus rules. Those are the incoming transactions in blue. This goes through, it doesn't matter which miner. Again, we're talking leaderless. It goes through this decentralized filter, which is the consensus rules, and out the other end, the red is the blockchain. That's what comes out of the decentralized mining process. And the red are transactions that are confirmed, secure, the entire network agrees that there's a high level of security associated with each transaction. Now, the way the blockchain works, it's kind of like a stack of blocks, one on top of the other. Your transaction goes into a block. A block is essentially a container, and then that's confirmed by the miners. Now, this process repeats over and over and over again. Every 10 minutes on average, there's a new block that references the previous block. It says, I trust all these other blocks back down to January 5, 2009, the Genesis block, and these latest transactions. That process continues ad infinitum. All transactions pass through that decentralized filter that says you're either complying with consensus rules or not. Next slide, please. Oh, and just an audience note. I come from the Linux world, which says you're allowed to interrupt the speaker. So if you have questions, just shout it out, raise your hand, etc. We're very easygoing here. So consensus rules. This is essentially a breakdown of how they work. Everyone must follow these rules, but again, it's an almost a paradoxical problem. How do you come to consensus on consensus rule changes? So we have several methods right now being discussed of changing the consensus rules, but none of them are perfect. All of them have advantages and disadvantages. Now, these are called hard and soft forks. A fork is just like a fork in the road. That's where a certain set or subset of people start working on a new set of consensus rules. Next slide, please. So talking about soft forks are a specific method of upgrading the consensus rules where not everyone on the network has to agree. Only the transaction validators in that choke point have to agree. So the big reason why everyone loves soft forks and why they're looked at as a method for upgrading is that it does not cause what's called a consensus failure. The chain itself, the blockchain, continues to make blocks, and you're relying on the miners to validate the new set of rules, such that old nodes, old computers, they don't have to upgrade. But here's the key point in governance: you're now trusting the miners rather than operating a trustless piece of software. So that's some of the trade-offs with soft forks. Is it's backwards compatible, so software doesn't break, but the new rules are essentially being decided by a tiny few and enforced by a tiny few. So you're inserting trust into what was previously a trustless system. So there are various advantages and disadvantages. The primary advantage is that it's backwards compatible, and it is very difficult to reverse. It's what's called asymmetric. It's easy to execute, but very difficult to undo. So from the standpoint of blockchain security, that's good. From a standpoint of governance, perhaps not so good. Is it increases software complexity, because now you have some computers that are aware of the new rules, some computers are aware of the old rules. You have, it's not opt-in, and I'll explain that on the next slide. And most importantly, the user node security is reduced without your consent. You're running a node, it understands the current consensus rules. After a soft fork, if you don't upgrade, your node no longer knows all the rules and no longer can apply itself to all the rules. You're trusting a miner. And inserting trust into a trustless system is a risk. Next slide, please. So this is what happens in a soft fork: is this decentralized filter, the miners collude or agree that they're going to change the consensus rules for the network. Since every new transaction on the Bitcoin network has to go through this decentralized filter, everyone in a soft fork, after that soft fork upgrade occurs, has to follow these new rules. Now, obviously, that's a governance issue because there's no user consent for these new rules. They were just simply implemented on the network by the miners. There's another technique we can discuss called a user-activated soft fork, has similar issues. Basically, a small few decide that the rules are changing, and the rest of the users are just pulled unwillingly without their consent onto the new rules. So key point, there's no explicit user consent on these upgrades. Next slide, please. So I liken this to having click yes for auto update for your constitution. Is that these are fundamental rules for the network, but a soft fork says that we can upgrade these rules and I have no say in the matter as an individual user. So you can see that up there are some examples of how soft forks can potentially be negative. Some soft forks in the past, explicitly BIP66, which is a Bitcoin improvement proposal, that rejected a certain subset of user transactions on the Bitcoin network. After BIP66 activated, some users with buggy software related to digital signatures could no longer transact on the Bitcoin network. So I highlight that example only because it is commonly claimed that soft forks on the Bitcoin network, they're opt-in. That's not true at all. It is the exact opposite, is the rules change and you have to comply with those new rules whether you like to or not. Typically, software keeps operating, but that doesn't change the fact that it's new rules and everyone is subjected to those. For that reason, Ethereum creator Vitalik Buterin, and the link there gives you some explanation. He calls softworks coercive and anti-market. It's essentially, a tiny few cadre decide some new rules. And in my personal opinion, that's sort of antithetical to the Bitcoin ethos. Next slide, please. So TLDR, softworks are backwards compatible, but that's at explicit odds to governance. So if you have backwards compatibility, if you have auto upgrade compatibility, it's very easy to upgrade the software without breaking. Then that is at direct odds with upgrading these new rules that everyone must comply with. If you have this auto update, then by definition, you don't have consent for the new rules. So that creates a power imbalance that a tiny group can make decisions for the majority of Bitcoin users. Next slide, please. So hard forks, again, the going back to the starting slide where my point of view is ultimately pragmatic. It's what are the benefits, what are the risks? There is nothing safe or unsafe definitionally. It's not black and white, everything has benefits and risks. Hard forks are another method of upgrading the Bitcoin consensus rules, and it has a high user consent value. That's the advantage. On the governance side, it's basically the opposite of a soft fork. But, and this is the disadvantage, is that it's disruptive to the network. So if we have what we call an amicable hard fork, that's an upgrade where the miners, the developers, the users, everyone is happy with that new path. That's the safe path. And that's locked in by the hash power, everyone's software, everyone's Bitcoins are secure. In contrast, the contentious hard fork, that's the Ethereum ETH Classic type situation where you ultimately wind up with a permanent split, 2 coins, a lot of market chaos, a lot of user confusion, and so ultimately not healthy for Bitcoin from that user experience perspective. So those are really the benefits and the risks of the hard fork as well. This was the original path suggested by Satoshi, and for the first 6 years of Bitcoin's life, this was the assumed upgrade path, is that there would quite simply be a flag day that says, if, April 4th, 2017, then the capacity increases. It was going to be that simple. Times have changed and opinions change, and now there's a lot of debate around that path, but that was the planned path for Bitcoin for the first 6 years of its life. Next slide, please. One of the proposed upgrades is something called segregated witness, or SegWit. And very explicitly, again, I'm not a absolutely yes or absolutely no on all of these issues. Is a very nuanced view. There are, again, benefits and risks. The benefits, I call it a Lego block. A very, very useful Lego block that you're going to build other things on top of. So that's what I mean by foundational. So under the benefits column, it's foundational, and it eliminates an annoying problem called transaction malleability, which in turn creates hurdles for high-speed payments such as the Lightning Network. So very good upgrades on that positive side of the ledger. On the negative side of the ledger, on the risk side, it's the first economic soft fork. And again, this comes into the governance issue of if we're doing a soft fork, which as explained is just a small group of individuals, do we really want a small group of individuals setting a new economic policy for Bitcoin? So that's one of the big questions with SegWit, and why several notable people have problems with that particular path. It's a voluntary upgrade, and so one of the selling points of SegWit is that it increases capacity on the network, but if it's a voluntary upgrade, then you are not required to upgrade, therefore it will be a slow increase in capacity, not a rapid increase like most people want. And so it will not address the high transaction fees, transaction network congestion, etc. Question? No, that's a great question. Is the way SegWit works is it splits every transaction into two pieces. And one piece is stored in what you'd call the Bitcoin blockchain today. And the second piece is sort of stashed in a secondary data area so that it doesn't count in terms of transaction fees. There's a discount associated with that. And so to get the benefit from this transaction capacity increase, you can do one of two things. Number one, you could do nothing. And if everyone else upgrades, you benefit from the added transaction capacity because people are using this technique to get some data off the main network. Path two, you can upgrade and you will directly get a little bit of a discount in terms of your data is now segmented along that along those lines. And so either path, assuming, and this is the key, assuming that a mass also upgrades, you will get benefits. And that's the main question, is will the mass of Bitcoin users upgrade or not? If not, then it's a big complex upgrade for very little gain. If yes, then it's a foundational upgrade that benefits users who, even if they don't upgrade, they receive a capacity discount. But what we see in chain, again, field data trumps all. What we see in chain with voluntary soft fork upgrades is that it takes years for wallets and other software to upgrade to this new feature. And so based on existing in-chain data, the best field data we have, if SegWit is rolled out into Bitcoin, that capacity increase would be very slow. So that's again very, very nuanced. It's not an easy yes or no type of answer or situation, but that's really how these upgrades, incredibly complex upgrades, fall out. Next slide, please. So again, SegWit introduces some economic policy changes, and this is very specifically why I think soft fork plus SegWit is bad for governance, is that you're rolling out economic changes, an economic policy change for Bitcoin with very few people initiating that change. And so these are some of the economic changes that SegWit rolls out in that upgrade. So that analogy is sort of the best analogy that I can come up with is transactions on the Bitcoin network. They're sort of like water filling a bucket. And right now we have a 1 liter bucket every 10 minutes that we can fill up. What SegWit does is it adds a second bucket that you can put some of the water in. And so it relieves some of the capacity congestion, but not all of it. So that's really how SegWit changes some of the economics of Bitcoin, as well as providing transaction capacity, as well as being foundational in terms of technology. Next slide, please. So one of the things that I like to point out is that Bitcoin is very predictable, and it was programmed to be predictable. Every 10 minutes on average, there's a Bitcoin block. There are guaranteed to be 21 million Bitcoins. Every block reward is predictable ahead of time. I know, 20 years looking forward, exactly how much currency supply is going to be introduced into Bitcoin. It's very predictable. The block space in a hard fork proposal, again, very predictable increase. With SegWit, since it's voluntary opt-in, it introduces two areas of unpredictability, which is, again, a little bit contra to typically how Bitcoin is operated. Number one, this added capacity. This added capacity is, since it's opt-in, you cannot predict how much capacity will come online. There's the more pessimistic side of the predictions, and that's sort of where I land, is in-chain field data says it's going to be a slow capacity increase. Some of the supporters who are more on the optimistic side, they say that there'll be a much greater, much faster ramp up in terms of capacity. But point being, you don't know. It's opt-in. It's unpredictable. And since we're talking about a fixed supply resource, going back to Economics 101, what happens if, for example, I control, with my magic wand, the housing supply in Amsterdam, and there's 1 million residences. I wave my magic wand, and the next day there are 2 million residences in Amsterdam. What does that do to housing prices? What does that do to rent? All of these economics have the same trickle-down effect as when you increase capacity. If Bitcoin, as today, has 1 megabyte of capacity, you double that. In economic terms, that's called a supply shock, because you have a sudden increase in supply. Therefore, all of the market participants who are bidding at, say, $1 per transaction at the 1 megabyte level, they have a totally new market to bid into when transaction capacity doubles. So again, there's that unpredictability factor with regards to SegWit. Similarly, in terms of unpredictability, you don't know what time frame this capacity is going to be delivered on. Will it deliver another megabyte of capacity in a month, in 6 months, in 5 years? You don't know. So 2 elements of unpredictability were introduced as well. Next slide, please. One of the things that I like to highlight with regards to technology and maturity is something that I imported from my last experience building open source satellites. So a little humble brag, since the business failed and there are all sorts of jokes related to that, is I built the first open source satellite. And but it was a great learning experience. I interacted with all of these quote unquote steely-eyed missile men who, you know, if you think about a SpaceX rocket or something like that, those are really ICBMs that you're launching into space. And so you have to deal with governments, you have to deal with all these rules, and most notably, you have to deal with unproven technology. And so NASA's come up with this technology readiness level scale, which allows you to evaluate, is the technology on paper, is it working in the lab, is it tested in the field, is it repeatedly tested in the field, flight proven, it's actually made it to space multiple times and survived. And so what we need to do as a community is to follow these sorts of evaluations with any new technology, whether it's segregated witness or the Lightning Network or Bitcoin Unlimited or Bitcoin Classic. Pick your change, pick your new technology. This is how we create a level playing field. There's a lot of promotion in this space, and a lot of that is perhaps mindless promotion. And this is really how you level set and get back to science. As you say, how close to reality are these? How close to the field are they? Do we, most notably in the Bitcoin community, need to wait for SegWit and Lightning to be mature and have a fully proven economic model before we have usable payments in Bitcoin? That's one of the existential questions that's being asked right now. Next slide, please. So that's why I say mind the gap. Mind the gap means that right now, Bitcoin payments are being priced out of the system due to high transaction fees. Both BitPay, a payment processor, Shapeshift, a instant exchange, and some other Bitcoin businesses, they've already sent out notes to their customers that say anything under, say, $5 value is economically infeasible. And so we're just not going to accept payments that low. And as transaction fees increase, that is only going to exacerbate. And so right now, literally, the payments are being priced out of Bitcoin. But we don't have a replacement yet. Everyone talks about, and I'm a big fan of, the Lightning Network, most notably. The Lightning Network is thought to be a payment replacement where you can do thousands of payments per second, but it's not done. And so should we embark on a path? This is a rhetorical question for the Bitcoin community at large. Should we embark on a path that sees wait for SegWit, wait for Lightning, and then only step 3, do we know, did we go down the right path or not? You spend several years and you don't know exactly how far down the path we are and what's our plan B if that path is not to be successful. So that's what I mean by mind the gap, is that users today are left with a poor user experience and no actual in the field solutions. And so that's the situation where we have Bitcoin Decision Point today. Next slide, please. So in conclusion, be pragmatic, mind the gap. We don't bet Bitcoin's future on technologies which aren't yet proven at scale, aren't yet even out of the lab for the most part. A tiny few should not really be in control of Bitcoin, whether that's me or anyone else. That's the antithetical to Bitcoin's ethos. Soft forks in particular, they're neither opt-in nor risk-free. We have to be honest about upgrading the network. Upgrading the network always involves risk. Just like upgrading, changing the US Constitution, the Constitution of the Netherlands. And time has real cost. We can't just pretend that Bitcoin is an academic experiment where we can, let's see if this works. If it doesn't work, let's see if this works. There are real people, real economic decisions being made every day. And so it's potentially very risky and costly to conduct a large-scale experiment on Bitcoin to see, will SegWit and Lightning provide a good payment experience? If not, we just travel down a multi-year path that turned out to be the wrong one. That is ultimately Bitcoin's decision point today. And that's why I say be pragmatic and mind the gap. Thank you very much. That's Bitcoin and my thoughts.
Yeah, thanks very much, Jeff. I already asked Jeff before his talk if he was going to share with us a prediction on how it's going to pan out, and he had mumbled a bit about
I
not
had a
asking
very
engineers.
surly answer, didn't
right,
I?
not asking engineers to make predictions.
That's right.
Right.
Engineers are the worst prophets in the world. Don't listen to us.
Right, but I think maybe what you might be able to say is how will we know when we're getting close to a decision here? Like right now, everybody is, I mean, if you read the press, there's chaos in the Bitcoin community, right? How will we know when we're starting to get this figured out?
No, that's a great point, and I'll readily admit I don't have a cut and dry answer for that. It's really very subjective when you see that the core developers, the miners, the user community are subjectively arriving at a particular path. That's when you'll know. That's not a very satisfying answer. It's very subjective, but that's the real answer as well, is that there's a lot of disagreement on which of these paths need to be taken. And there's a lot of animosity on various sides that feel that, this guy is an entrenched player over here, this guy is an entrenched player over here, and they're at loggerheads. And so there's a lot of personality drama and that sort of thing. It goes part and parcel with the Bitcoin decentralized experience. Ultimately, we're all figuring out, again, how to lead a leaderless system, how to come to consensus on consensus rules.
Jeff, don't we already have a forking system? I mean, if I see really clearly that they're very intelligent and capable people on both sides of this debate, and we've been following it endlessly. Why don't the people who want to fork it just hurry up and fork it? What are we waiting for?
There are a lot of people that agree with you.
We can have 2 viable coins and practically double our money. So the fact that they haven't done it yet, well,
I like doubling my money.
Right, or something close to that. So the fact that they haven't done it yet is weakening their argument.
Yeah, basically a lot of the business community is just sick of the entire thing. And like you were saying, Richard, when I stopped by for Tech Check, just freaking do something. Just make a move. It's been stalled for quite some time. It's been, loggerheads for quite some time, and the CEOs are just sick of it. You know, they're ready to see some action, some movement, anything but you know, progress being stalled.
Why don't we take a poll? You can do it.
You word the poll. I'm poor at wording polls. But audience participation is great.
I will try, and maybe you guys can help me word the poll.
I think he's already voting. Look at him. He's
Yeah.
voting for something. Look at that.
Shall we do this now, just to see what how the audience feels? How many? Let's see a show of hands. People who don't really know very much about this debate to form an opinion yet. Let's see a show of hands. Okay, so all of you, keep your hands up. Can someone do a quick count for me? Keep your hands up. Keep your hands up. Is there a total? Can someone give me a total? How many? 20? About 20? Okay. You guys who voted, please don't vote again. All right? So how many are very firmly in favor of a increase in the block size? Yes. How many do we have there? Well, I mean, this would be a Bitcoin Unlimited kind of vote, right? Right? Right?
Yeah, that gets into the problem of once you go for a specific solution, then you know, the vote counts go down.
Well, let's say simply increasing the block size, a simple increase. Yeah. Okay. How many? How many is that? Can someone count? Anyone counting? How many? 40. I want an accurate count.
No double spending of votes allowed.
Was it 40? Do we have 40? Yeah? 37. 37. All right. And then the last one is a Bitcoin Core. Who supports a Bitcoin Core? What?
You're not offering compatible things to vote on. They should be mutually exclusive.
Yes?
So there's no such thing as Bitcoin Core. There's a bunch of different people that do different things.
Correct.
Okay, so are you saying that's,
Okay, so shall I say
No, let's go back to the question. It's like you're not going to resolve anything here. It's all in the process.
We're not resolving anything here at all. We're doing a very messy. No, absolutely not. No propaganda whatsoever. So, who would be in favor of the SegWit solution? How many do we have?
Again, I can't help but point out, like, I'm in favor of SegWit. I'm just in favor of SegWit as like a hard fork. And so, you know, again, it's very nuanced. Is you know, the current roadmap is SegWit only as a soft fork. So I would word it as that option. Please.
Yeah, let's go. We had a few questions. You want to take the mic?
Sure. Or just be loud.
What would your path be?
That's pretty much like I just said. Is I think the SegWit's valuable, but it's has governance problems as a soft fork.
Right, but
so I would say block size increase plus SegWit.
Okay, to what? 2 megabytes? 8 megabytes? Just anything.
You know, it's basically not too big. The current data supports about 4 to 8 megabytes and not more than that.
Okay.
If you want to get global distribution, global validation. And so based on current data, that would be where I'm at.
Okay, thank you. Oh, wait. You have a question?
Yeah, I have the same question.
Oh.
Comparable. So that's the blog that came out a couple of days ago, I think, combining SegWit and Bitcoin Unlimited.
Sergio.
Yeah.
Just to be very specific, that was not a combining Bitcoin Unlimited. Bitcoin Unlimited is a bit different. The Sergio proposal, I definitely support that. That's basically a capacity increase to 2 megabytes, and then SegWit, which also offers some additional capacity. But that's different from Bitcoin Unlimited.
I'm going to try to do a bit order people. You've been raising your hand all the time.
So you mentioned you like field testing a lot. That's one of the first points I think you said. Would you think something like Litecoin could be a good route for this? So
No,
basically
absolutely.
something that's very close to Bitcoin, segregated witness is pretty much activated, just a few percent.
Yeah, I've tweeted that, in fact, is very specifically Litecoin has been doing a good job of following the Bitcoin code base. So whenever Bitcoin adds some new features, the Litecoin developers pick that up. And specifically, if you're a Bitcoin holder and SegWit is coming down the pipe, you absolutely want field testing for SegWit before it activates on Bitcoin. And Litecoin is the perfect test bed for that. And so, you know, it's a bit of a cynical position, right? So if SegWit fails horribly, then Bitcoin users are unaffected. And if SegWit succeeds quite well, then Bitcoin users can pick it up and benefit. So it's win-win for Bitcoin to have it tested on Litecoin. And that gives it field testing, you know, field data, and that's absolutely what's needed for SegWit.
Do you think that some of the people that are speaking out in favor of these various so-called solutions, what percentage of their advocacy would you say is technical in terms of this is a better idea technically versus financial, as in I'll make money off of this solution? Can you name some names, please?
I'm going to pick answer C, which is there's what you see is you sort of see the Bitcoin Core roadmap and Bitcoin Core path, and then you see a lot of little efforts splintering off of that. And so I don't like to name names specifically because I think that gets away from the science, gets away from the data. So I'll just generalize and say that there's a lot of dissatisfaction with the current core development team. And so these efforts like Bitcoin Unlimited, SegWit 2 megabyte, Bitcoin Classic, those are really sort of efforts that are trying to widen the scope, both team-wise, software-wise. There's a lot of people who think on the software side that a monoculture, a homogeneous monoculture of software is very bad. You have a bug in one piece of software, it impacts everyone. Whereas if you have multiple implementations and multiple teams, then you don't have a single point of failure either on the people side or on the software side. So that's just sort of the generalized theory, but I think the answer to your question is it's really the path C. It's not economics. You know, miners, they'll definitely make more revenue, whether it's Lightning or a on-chain scaling. It's more about one team, you know, having control over economic policy in Bitcoin and dissatisfaction with that path. And so that's how I would sort of boil it down.
Yeah, I'm going to do, unfortunately, we're still waiting for 2 more speakers. So I'll do last question, and then we'll have more time also for breaks. Yeah?
Hi, I'm Nathan Jasper. What is your opinion on several altcoins like Dash who are solving problems Bitcoin has in transaction speed? Do you consider that as a threat for the position of Bitcoin?
In theory, you could make that argument, but I lean towards no, in that Bitcoin is the most secure coin right now, and it seems like that's going to continue. And so the logical path for Bitcoin is sort of like the SegWit example, is that, you know, the Dash, the Ethereums, they can prove features in the field, and if those features are field proven, we can integrate those into Bitcoin at a later date. And so again, it's like that Litecoin example, is let them take their lumps, and then whatever survives, the survival of the fittest, we can integrate into Bitcoin. So I see it all as healthy. You know, I don't see Bitcoin being supplanted by a Dash or something like that. But I think that it's very important to encourage all this innovation, whether it's in Bitcoin or elsewhere. You know, always encourage innovators. I think that part of our community is a bit negative on any innovation that doesn't come through a sort of blessed path. And that's not very healthy for science and for innovation in general. So while I'm you know, what I call default Bitcoin, I think, like I said, Bitcoin's going to continue to be the most secure. Is we can't just shoot down alternate coins, alternate developers. You know, we have to be professional. We have to be positive.
Okay, Jeff, very big thanks. I think Yeah, really. I think it unleashed quite a lot of energy in the room as well, and hope we can continue the discussion also after we have the other speakers. Yeah, thank you very much.
Thank you.
I would like to invite now Dominic Williams. He's also a big traveler, traveling back and forth between San Francisco and Switzerland, and of course speaking engagements like this. Dominic is both the CTO of String Labs as well as for DFINITY, which are connected but separate entities. And we're going to hear today mainly about DFINITY, I understand correctly?
Yeah, sure.
Very much looking forward. Thank you very much.
Great. Hi.
And I think we still need to get the portable microphone on you. Is that what's still being
Does
used?
this work? It's probably okay. Maybe.
Go ahead. Yeah.
So I'm just curious, has anybody heard of DFINITY here? Okay, so a few. That's great. DFINITY is a new kind of blockchain computer network. It's under development. In the vein of Ethereum, I suppose, with some very key differences. Do you want to roll it? We're sort of pursuing a vision which is best described as a decentralized cloud. And the vision involves a blockchain computer that has infinite scale and capacity and can be applied to run vast amounts of business logic using smart contracts, and such that it can benefit from the special properties that smart contracts provide. So, just quickly, I mean, just trying to put things in context. Back in 2008, Satoshi came out with the world's first stateful decentralized network, and what that means is that all of these decentralized clients could talk to each other over a P2P network using gossip, and by following the protocol, they could conjure a virtual ledger, right? And this was a shared virtual ledger. This was the essential thing. If there was a Bitcoin on that ledger and I spend it, then you couldn't spend it, right? We all eventually had the same view of the ledger. But the ledger, of course, was a very simple thing. It was a bit like a spreadsheet where you've got different addresses, and at these different addresses, you've got balances of Bitcoin. And these Bitcoins are protected by little access control scripts. And, over time, some people felt that this vision was very limited. And eventually in 2014, you had the Ethereum network. And the Ethereum network is a very similar thing. You have a P2P network, and all of these clients are talking the protocol over the P2P network. But now, instead of having a virtual ledger being conjured by the protocol, we have a virtual computer. And a virtual computer is what I refer to in this case as a blockchain computer, is a much more powerful thing. We can upload software to the virtual computer and we can run it. Once software is on the virtual computer, we can send transactions to it, which are really calling the methods in these persistent objects that we refer to as smart contracts. And this provided a means to develop a whole new generation of decentralized applications that weren't possible before. And you might call that the second generation of blockchain. And we're sort of shooting towards the third generation of blockchain, where a lot of new cryptography is being introduced, new network protocols, new kinds of math that make it possible to scale this blockchain computer, right? And also increase the performance. So in this slide, we're looking at one of the, realization of one of the objectives, which is to improve the performance of the blockchain computer. So if you look at, the Bitcoin network, in expectation, you get finality in about 60 minutes. It can vary wildly with the Poisson distribution, of course, but 6 blocks gives you finality. You expect to see a block in 10 minutes, right? The Ethereum network still uses proof of work, but it introduced something called Ghost, greedy heaviest observed subtree, which is like a sort of tree, and about 37 confirmations give you finality in about 10 minutes. in the new protocols, we're using applications of a sort of new kind of cryptography, which can give you much better performance in a public network. So, you know, you'll see finality on the DFINITY network, and we have prototypes running. You know, we've got various cryptography professors and so on working on this stuff, and you're going to see public network finality in under 10 seconds. So it's a huge improvement. So in the same way, you know, that Ethereum provided a huge speed up over Bitcoin, you know, we're going to provide another huge speed up, about 50x speed up over Ethereum today, which is very significant. Next. So this is another key idea. So if you went back to the 1990s and you were involved in the dot-com boom, I was, when you created a web service and that web service became overloaded, what you would do is you'd phone up Hewlett-Packard and you upgrade your web server and you say, give me a, I don't know, Proliant DL 385 or something, and you get this server delivered to your hosting center and install it in the hosting rack. And this is called scale up, right? Every time you run out of capacity, you get a bigger computer, right? The problem with that is it only goes so far, all right? And you know, after 2000, with the advent of social networks like Facebook, there was a proliferation of new technologies that enabled systems to scale out. So an example of a scale-out database would be Cassandra, right? You can just continuously increase its capacity by adding new servers. Actually, these servers talk to each other with a kind of gossip network. I was involved in that. For example, Cassandra now powers Netflix, you know, right? You know, thousands of these servers, right? I forget what proportion of the internet's traffic comes from Netflix. So the idea is, you know, that we want our, you know, decentralized blockchain networks to scale out too, which means that as more miners join the network, the capacity of the blockchain computer increases. So we're not just optimizing. So, you know, the previous step to give you that speed up, 50x speed up over Ethereum today, that's scale up in a way, right? That's just new cryptography and new protocols to make it run faster. Scale out is a whole different thing altogether. It's much more difficult to achieve, and it involves the capacity of the blockchain computer increasing as new miners join. Next. So there's another thing. I mean, DFINITY was conceived. Actually, the project goes back to 2014, but the network is conceived as a sister network for Ethereum. We're working on shared components, and we're trying to push a lot of our crypto and protocols into the Ethereum project. And so, you know, how could it be a sister network and not overlap and be something new? And we're introducing a kind of algorithmic governance system called the blockchain nervous system, which turns a lot of ideas that you're familiar with inside blockchain on its head. So, you know, traditional blockchain has this idea of the code is law, right? And the code is law means that, you know, you have a smart contract, for example, and the smart contract, you know, comprises code, and you know how that code is going to execute, and nothing can change the data associated with the smart contract, and nothing can interfere with the execution of the smart contract. In DFINITY, it's very different to a traditional blockchain. You have an algorithmic governance system, which you can think about as something that applies algorithms to sort of crowd wisdom to make decisions. It's a bit more than that because you can integrate it with traditional AI. And this blockchain nervous system has access to the virtual machine itself, has privileged instructions in the virtual machine. It can freeze contracts, redistribute tokens, it can upgrade the protocol, it can run arbitrary code that has access to these privileged instructions in this case, the EVM, right? And so, for example, if you had something like the DAO occurring, you know, the blockchain nervous system can adopt a proposal to try and mitigate that by running some privileged code that will, you know, run without restrictions. It can, you know, change software code, change data, right? And so it's a very, very different kind of idea. And I suppose it's kind of pertinent as well. Jeff was just on talking about Bitcoin's problems, and we've seen how, you know, development in Bitcoin is really ground to a halt. It's very, very difficult to make anything happen because nobody can agree. Now, the problem with blockchains, of course, is that you can't just say, okay, we're going to have a governance body, because a governance body would be an intermediary. And the whole point about a blockchain is that you get a sort of geopolitical security. You know, you're not rooted in a jurisdiction. These things only exist in cyberspace, right? Because you don't have a server running these things. There's no authoritative record of state. You just have all these clients talking a decentralized protocol, and as a consequence, you get a virtual ledger in Bitcoin or blockchain computer in Ethereum and DFINITY. But that computer doesn't exist in some country. It just exists. It's a virtual thing that exists in cyberspace, and various benefits flow from that. So you don't want to introduce a traditional sort of corporate style governance system, right? Because that involves people that are sitting in some regulated jurisdiction, right? And there's all kinds of issues that flow from that. Next. The basic reason for the research is to create an infinite blockchain computer and address performance challenges. And there are two kind of big opportunities that we're pursuing. On the one hand, we want to create sort of open source tech intermediaries. So we want to see the creation of open source, Uber, open source eBay, open source social networks, right? But also even things like web search engines. And this is where it gets really interesting, because the traditional wisdom is that you can't run any kind of thing that requires enormous performance on a decentralized network. And it turns out that when you really drill down into the science and some of the new stuff, that's not quite true. So that's at one end of the opportunity spectrum. The other end just involves corporate reengineering, and we'll get to why that's the case. Let's skip forward. Just to give you a quick overview of the project, it really can be traced back to 2014, and there was a lot of work that was done on a cryptocurrency called Pebble, which was going to be focused on micropayments. And this actually was researching mainly derivations of a thing called BFT consensus, which comes from a branch of distributed computing, which lives on in various popular protocols being applied at the moment in things like banking, right? But actually, DFINITY refocused on developing an infinite blockchain computer in 2015, using a new idea to do with randomness. Like the whole network is based upon the generation of random numbers in a secure, unmanipulable way in a decentralized network, and then applying these random numbers. And so it's a whole sort of new way of thinking about how you can run these decentralized networks. In 2016, DFINITY Stiftung was created. It's a not-for-profit foundation in Zug. The DFINITY project was incubated by a company called String Labs, which is like an investor and incubator in Palo Alto in Silicon Valley, where I've come from. And then this ran a kind of seed fundraising in February. It's got about $10 million in assets for initial development. You'll probably see a test network appearing in July. And then shortly after that, there'll be a kind of main round where you'll probably see another $20 million coming into the project. So it's a very well-funded project. And of course, it's also got an endowment of DFINITYs and so on. So there's a lot of money for R&D. And if anyone's interested in, if there are any engineers here that are interested in this kind of work, please see me afterwards. Next. So let's skip quickly through this. I mean, this is how we see the EVM ecosystem. The EVM, as you probably know, is Ethereum Virtual Machine, right? Which is the thing that you build the smart contract software on top of. The EVM is an open standard. Ethereum is underpinned by these ideas. The code is law. The community performance management. In extremis, the community can hard fork to fix a problem or hard fork to upgrade the software. And there's a new system called Casper being developed, which I'd call it availability favoring. Go to the next slide. Thanks. So DFINITY, also supports the Ethereum virtual machine, right? So if you can run a dApp on Ethereum, you can run it on DFINITY. If you know how to write Solidity smart contracts for Ethereum, you already know how to write Solidity smart contracts for DFINITY. The differences are, at the lower level, DFINITY has this idea of the AI as law. It's basically algorithmic governance rather than the code as law. And then we have all these new cryptography and new protocols, which is sort of loosely referred to as Crypto 3. So the next. So the reason for this is just dry, don't repeat yourself, extend, don't imitate, and you can see there are sort of fundamental differences. And the next. Yeah. So I think the vision behind this is that common standards win out. Developers don't want to learn new skills all the time. So there's already a big army of people that are learning how to write software for the EVM, and I think this just reflects a sort of broadening out of the EVM ecosystem that's going to make it even stronger. It's going to be very difficult for chains that don't support these open standards to compete, right? Next. So decentralization vision, currently, if you look at the cloud, the machines behind something like Amazon Web Services are located in a rather small number of data centers, okay, which is a fragile architecture, obviously. We see that being much more distributed. The new kind of protocols and cryptography underpinning them, create far more decentralized networks than you see today. Bitcoin really, I know a lot of the big Bitcoin miners personally. It's incredibly centralized, right? It's not really a decentralized network. You have relay networks that the miners use to move blocks around. If you look at Ethereum today, even the P2P network isn't really a P2P network in the sense it's meant to be. You've got a kind of hub and spoke architecture where everyone's hanging off these super nodes that are run by the foundation. So, we envisage a much more decentralized network, and certainly nothing like pooling. There's no economic advantage. There's no mining with spending. Today with Bitcoin, participation is just mediated by the burning of electricity, really. Whoever has got the cheapest electricity can outcompete everybody else, right? And make more Bitcoins. So it's not fundamentally not a decentralized network, because there's always these massive disparities in the price of electricity. And if you're in Inner Mongolia and you've got one of these coal-fired power stations that were built by the Communist Party to bring industry into the desert, right? Of course, no one wants to build a factory in the desert after all. It's just all Bitcoin mines, right? The price they're paying for electricity is a tiny fraction of what we're paying here. So you're never going to have a decentralized network where you mediate participation using electricity, right? So anyway, these are examples of consumer mining devices that are kind of being constructed by String Labs at the moment. Next. So this is the vision that these kind of core public services are moved onto the blockchain computer, right? And that's things like sharing, microblogging, not email, but kind of secure messaging. Even things like search. And this, I think, is one of the big transformations we're going to see in the next 10 years, beginning to occur and then accelerating. But if you look at Silicon Valley today, the model is that you look at an emerging area as a specific need. You'll have the best kind of competitors. A huge amount of venture capital flows into them. But the objective is always to create a monopoly, right? The money doesn't really come from the technology. The money comes from the creation of a monopoly, because once you've created a monopoly, it's very, very difficult for new entrants to come in and compete, and you can just then sort of milk the position, and that's where the huge profits are realized. And I think the future will be very different. We're going to see open tech intermediaries, right? And there'll be DAO-like governance systems which adopt software updates, and they'll develop much faster, and there'll be bug bounties and feature bounties, and people will propose things. And it'll be a very different kind of landscape to what we see today. Next. So I won't try and explain this too much, but there are certain features of DFINITY that make it possible to develop much more powerful decentralized applications. One of the projects under development at String Labs, which I would recommend that you go and look at, is called Phi. And Phi is a project to create a crypto fiat, okay, which is very different to a cryptocurrency. Because one of the things we found looking at decentralized finance is that, in practice, a lot of the applications that you want to pursue are out of reach, because, the cryptocurrency that you're using is too volatile. So you can look at something like a prediction market, right? Like an OSIS. Well, fine, we can all go and place bets on the prediction market using Ether, for example. But the reality is that the actual currency that you're collateralizing those bets with is far more volatile, right, than the thing you're probably betting on. So anyway, this project Phi is aiming to create crypto fiat, and it sort of mimics the way the commercial banking system works, where currency is created for loans, and so you create currency that's backed by loan assets. But it does this autonomously by using randomness. It's able to use random sequences of validators to originate loans, right, with an algorithm. And so this randomness is a very, very important feature. You can't, once you have it, you can do all kinds of really interesting things. Next. So DFINITY, is kind of focused too on the enterprise, and this again, I think, is a very misunderstood area. Traditionally, we all think about the blockchain as this very slow, expensive thing that can just be used for high-value fiduciary kind of transactions. And I think the point, and this thinking, obviously extends to blockchain computers, and it's certainly true that while we can make a blockchain computer that scales out, and that's coming, and we can make a blockchain computer that performs much better than Ethereum does today, the cryptography and protocols involved will ensure that the computation on the blockchain computer will be many, many orders of magnitude more expensive than the computation on Amazon Web Services, right? Like if no matter what we do, no matter how much capacity the DFINITY blockchain computer has and how performant we make it, when you implement your business logic in smart contracts and run it up in the DFINITY cloud, it's going to cost you 100x plus more, the computation will, more than running on Amazon Web Services. So why, you might ask, is this kind of technology going to save vast amounts of money for corporate IT, right? And the answer, of course, is very simple, that the cost involved with corporate IT systems really has very little to do with the cost of computation. It's the human capital, right? Human capital makes up the bulk of the cost of corporate IT systems. So, one of the purposes of the blockchain computer is to enable the re-engineering and reinvention of corporate IT systems in a way that, sure, will involve computation that's much more expensive, but will enormously bring overall costs down by reducing the amount of human capital involved. And if you wanted a kind of way, perhaps, of understanding this, imagine you zoomed out from the world and tried to take a sort of distanced view of all the activity that takes place, and you would see all of these companies around the world hiring, network admins, database admins, right? Lots and lots of people doing the same kind of jobs, dealing with disaster recovery or backups and taking copies of data and snapshots of data and sending them to Amazon S3 and configuring all these Amazon components. And, you just think about it, from an abstract point of view. I mean, logically, is this a good design? We know it's a bad design, right? Fundamentally in computer science in your first year undergraduate, you're going to get taught this idea, don't repeat yourself. And yet we've got this system where everybody's repeating themselves en masse all around the world. Can't be a good thing, right? And without going into the details, or perhaps I should, in the future we'll be able to save a lot of money with these kind of systems. And you might imagine, for example, that we create, imagine you're in Dubai, right? And there's some kind of grade of crude oil that you want, that people have, grade G crude oil, right? This is the stuff that comes out of the well first when it's first drilled. I'm making this up, but you want to create a financial exchange for this crude oil, right? So the traditional approach is, you're going to need to get some exchange software, choose the database, maybe it's Postgres, you got to configure it. This is like mission critical software, master slave setup. You need a database administrator. Well, you can't have just one database administrator, because if this is mission critical, if you get sick or you're on holiday, right, someone's got to be there to keep this thing running. You need two of them. You're going to make it do snapshots. You're going to upload this stuff to S3, or you're going to run it in the cloud or whatever, right? Next thing is, you better be careful with your security, right? Because if a hacker gets in, you can go onto the database and say drop table star, or maybe modify the book or something terrible like that. Before you know it, you're going to have this team of database administrators, network administrators, security guys, web devs who are going to link all these things to, link the front end to the back end. You're going to need a HR guy to manage these individuals, right? And it's going to get expensive. And you're going to move on from there to other realms too. You're going to have a problem that your exchange is now in Dubai, which is a regulated jurisdiction, so you're going to have compliance issues there, right? So you better hire a lawyer to look after that stuff. And next thing you're going to do is you've got to convince people that your exchange is fair. So you better get some good people on your board, right? That's going to cost you money to show that you're a bona fide operator and this financial exchange can be trusted. And before you know it, you've spent an absolute fortune just building this team that's required to support this financial exchange in Dubai, right? The cost isn't anything to do with the computation of running the actual exchange. The cost is to do with the human capital, right? And in the future, we may see a very different kind of thing emerging where people are able to go up to GitHub, download the decentralized exchange system, right? Customize the front end, the DApp front end, upload this thing to the blockchain computer, and run it at a fraction of the cost, because guess what? You don't need backup restore, right? This is a redundant system that basically gives you guarantees about uptime. It doesn't fail. It's designed to be unstoppable, right? You don't have to worry about that. You don't have to worry about snapshotting your data and sending it up to S3. You can have your smart contracts log information that needs to be kept. And you don't need a security administrator, because guess what? The blockchain computer doesn't exist. It's entirely virtual, right? You can't log into the blockchain computer and get a terminal window and start fiddling with the file system and all that kind of stuff, right? It's very simple. I mean, you can upload software to it, and that software, the reason we call it a smart contract is because it executes as it is and doesn't do anything else, right? There's no, file system you can get into, no place to insert a Trojan horse, file permissions, or whatever else, right? So, you don't need that DBA. You don't need that disaster recovery program. You don't need the network administrator, right? And ultimately, what you see when you work with this kind of technology, and especially some of the new development tools like Truffle, not only is the actual development of these systems going to be greatly simplified, but the actual operational costs involved, the total cost of ownership will be dramatically slashed. And so that's another way I think we'll see kind of blockchain concepts turned on the head. Next. Yeah, so most of you are aware of this kind of stuff, I'm sure. There's a lot of work underway. DFINITY actually works with BCG quite closely, and we've got various large kind of corporate projects we're assisting with at the moment, with kind of Fortune 500 brand names you'll be familiar with. And blockchain brings these fantastic properties to software systems that mean you can reimagine. It's not just about reducing costs. You kind of reimagine a lot of these systems, right? And you know what these are. I mean, you've got no servers, so you've got no geography. You've got this kind of computational system in cyberspace. The system is tamper-proof. It's verifiable. It's very easy to create interoperable systems, right? And there's vast, vast swathes of the corporate landscape where these kind of systems can be reimagined. So this is something else we're going to see in the next 10 years. And that's, I think, why you see so many these big corporate players are interested in blockchain, but more specifically blockchain computers, right? Very interesting things you can do. Next. So, I don't. How much time have we got? Okay, I mean, I could stop. I mean, we could whisk through this blockchain nervous system, where I could take questions.
Yeah, I don't know. I think we should. I think you've already covered mind-blowing stuff.
Okay, sure. Go to question.
I don't know about the audience. I think there's probably already a lot of questions about what you've already shared.
Okay, sure.
It's really a vision that is indeed taking everything a step further than I think at least some of us in the audience have thought. Yeah. Are there any questions right now, or are minds too blown to? Yep.
Thanks. So using the block size debate as an example,
Sure.
Because you mentioned, using AI for
Yeah.
using AI for governance.
Yeah.
Since the block size debate involves subjective judgments based
Yeah.
on ideology,
Yeah.
I don't see how an AI could decide on such issues at all.
So, first of all, I mean, it's a hybrid AI. It's not just a sort of Bayesian classifier or something like that. These things can be plugged in, but fundamentally, there are things called neurons that are controlled by people. These things can be configured to vote automatically by looking at the output of other neurons, right? But fundamentally it's driven by, at some level, by human beings as well as traditional AI, right? So it will reach a decision, right? Proposals can be submitted to it, and if there's sufficient support, they can be adopted.
So, in a nutshell, what is the consensus algorithm then? Is it stake? Is it proof of work?
The consensus algorithm is single threshold relay and probabilistic slot protocols, which is it's like a.
If you could explain that.
It's a whole different thing, but the consensus protocol itself isn't actually involved specifically isn't a dependency of the blockchain nervous system. So the blockchain nervous system is implemented using software that is run on clients separately. Like, for example, you could run a neuron on your laptop, right, and configure it.
Right.
And there is a blockchain resident part, which is implemented using smart contracts that are privileged smart contracts that have access to special instructions in the virtual machine.
Is this like a bonded validator, or is it similar to that?
Well, that's the network. In terms of the neurons themselves, you make a deposit to create a neuron.
So, I'm just trying to get a straight answer here. So, is it if I run a node, then I have a vote based on my stake, or a
neuron isn't related to the network mining. It's a totally different system.
Right. But it's the neurons that are part of the consensus algorithm that form the governance. So, can you explain the governance then? What is the input?
Well, the consensus algorithm is a piece of math, right?
But it involves people. Like all consensus algorithm are, related to aligning incentives of the people that do make the decisions. So who makes the decisions in this network?
Well, hold on. So look, you need to kind of step back and imagine, first of all, that there's no blockchain nervous system, all right? And you have a network of mining clients that run a protocol, that involves new cryptography and so on.
Right.
That enables the network to produce streams of blocks and so on, and conjure some kind of virtual computer, and that works completely independently of whether or not you have a blockchain nervous system, just like with Ethereum, right? So Ethereum is moving from a model where a proof of work model to a kind of proof of stake kind of model. DFINITY doesn't have a straight proof of stake model in the sense that you're probably familiar with it. Mm-hmm. You create mining clients that are expected to have a roughly similar amount of provide a roughly similar amount of computational capacity, storage capacity, and processing capacity. But that and there's other things as cryptography. The new cryptography called the USIDs, unique state copy IDs and things like that. But that's completely independent of the blockchain nervous system. You could create, you could take these protocols and this cryptography and put it in Ethereum, and you've got a blockchain computer without a blockchain nervous system. Blockchain nervous system is a separate system, and you can create neurons completely independently with deposits, which have nothing to do with mining, nothing whatsoever to do with mining, right? And the neurons are controlled using client software that can be run, for example, on a consumer laptop, right? And these things can be made to vote manually, or they can be made to vote automatically by following the outputs of other neurons. So in the most simple case, you might say, I don't know how this kind of consensus stuff works, it's too complex, but I do know that I trust this developer or this set of developers, right? And you configure your neuron to vote based upon the output of neurons owned by these guys, right?
Like a representative type setup.
Like
having a representative in this case is similar to
it's
delegated.
A bit like delegated. It's a bit like delegated democracy. Yeah, it's a bit more complex than that, and it works like a black box. So you can't.
So what actually aligns the incentive of the decision makers then?
So if you were to look at this as a kind of hybrid AI, and you want to understand what its objective is, well, you'd first of all think, well, who controls the neurons, right? Why do they run these neurons? Well, they run the neurons because they can get some kind of rewards for doing so, but to create a neuron, you have to deposit definities into the blockchain nervous system. The voting power of the neuron is proportional to that. To get those definities back out of the neuron, you have to dissolve it, and that takes
so this
a
is
long,
very similar to
time.
bonded validators then in Ethereum. This is very similar consensus algorithm then.
No, but the blockchain nervous system has nothing to do with consensus. It's just purely a governance system.
Well, I mean, I actually, when I say consensus, I'm referring to the governance mechanism in this case.
Okay.
So
basically, if you ran a neuron and you put your definities into it, what do you care about? Well, you care about the value of those definities, and you know that if the blockchain nervous system makes a bad decision, the markets will punish the value of definities, right? So you can, if you like, look at the markets providing a kind of dopamine for the blockchain nervous system. The ultimate objective of the blockchain nervous system is to drive the value of definities higher. However that's done, and it can control economic parameters. It can upgrade the protocol, which happens transparently. It has a kind of like a reverse proxy around the client, and that can upgrade the client.
The way you describe it, it's not AI as law, though, in this case. It's still
no, this is, well, at least at the level we're discussing.
Yeah.
Without getting more complex. Yeah, it's it's kind of like delegated democracy or like liquid democracy.
Right.
Yeah.
Quite similar to Bond, but I don't want to hog the mic anymore, so I should pass it on.
Thanks.
Yeah.
I think you're asking a question a lot of us had, and you're best able to articulate.
That's good.
Yeah.
Well, actually,
but maybe then, how does the AI fit in?
So if you start with the most basic system, right? You have a number of objectives in relation to sort of more traditional blockchain goals, right? So you cannot introduce an intermediary in the traditional sense into a blockchain, right? Because you would lose. This is something that would be governed and so on. So similarly, if you have some kind of delegated democracy system, and it's much more complex than that, right? Because you can configure your neuron to vote automatically on arbitrarily complex rules that are being applied to the outputs of other neurons, right? So it's not, we're just simplifying here, right? But these rules that people configure into their neurons to make them vote automatically are configured in the neuron client software that they run on their own client. All of these neuron follow relationships, as we call them, exist at the edges of the network. So if you have 20,000 neurons being run, the follow relationships that will ultimately decide how this thing decides, right? Whether it adopts or rejects a proposal, all of these follow relationships exist on the edges of the network that are knowable. And this is very important because if you could see these follow relationships, right, you could maybe establish how it is, who is influential, and you could maybe blackmail them or extort them or bribe them. Or if, for example, there was a governance decision made to reinstate a Silk Road drugs market, right? Let's just say it'd been frozen, and then there was this ongoing debate about whether it was good or bad for the value of definities, and then there was a vote, proposal, someone puts a proposal into the blockchain nervous system. Let's unfreeze the Silk Road, right? And let's say it's you, everyone's somehow following you, and there's this complex series of relationships between neurons, and somehow, you're going to trip the blockchain nervous system when it cascades to a decision. And now, the government's kind of coming to you and saying, well, you're the guy that, you were responsible ultimately. We can show this kind of complex graph and sequence of events, and you were the guy that tripped the blockchain nervous system and made it unfreeze Silk Road, right? So you could then be, prosecuted or something, right? So it's very important that the blockchain nervous system acts as a black box, right? And that's one of the most important dimensions of this design. You can't see or predict how this thing will make a decision, right? But thinking for a moment about traditional AI, easy examples like a Bayesian classifier. I don't know if anyone knows, when you get like you used to get loads of spam back in like 15 years ago in your email, and that's pretty much disappeared. That's because there's a thing called a Bayesian classifier that's been trained on your email inbox, and it's been trained to identify spam emails, right? It learns right from feedback when people press the spam button, and it's very, very effective. And it's just basically applying this kind of maths from this guy Reverend Bayes that I think exists in around the 18th century. Anyway, the point is this: you could imagine that you would give a Bayesian classifier a neuron, right? A Bayesian classifier would control a neuron. And let's say that, the owners of neurons over time provide feedback on what they believe were good decisions, right? And that feedback is available along with context snapshots. You can now train the Bayesian classifier to have some kind of intuition about whether some proposals may be good or bad, right? And now people can choose to include this Bayesian classifier in their follow relationships. So you might, in this case, you'd probably use some kind of scoring system. So you'd say, well, I'm going to, vote positively on some proposal on this topic because it's, classified into different topics like protocol upgrades, economics, governance, and you might say, well, okay, out of this group of 5, I want to see a score of this amount before I adopt a proposal. And one of the inputs, one of the neurons in that group can be the Bayesian classifier neuron, right? Now, obviously, you probably want to get a bit more complex and have oracleize that classifier neuron. Otherwise, the owner of the classifier neuron could get everybody following it and using it, and then when he didn't like what it was saying, just turn it off, right? But yeah, you can see how that goes.
If I can just jump in really quickly, is an artificial intelligence that has properties of being unstoppable and tamper-proof and autonomous, isn't that what Stephen Hawking has been warning us against?
No. I think there's 2 parts to the question. The first answer is that I think in reality we're a long way away from the horrifying sort of general purpose intelligence that can trick us all, right?
Skynet.
Yeah. So and it won't need the blockchain nervous system to do it, right? It'll have other ways of getting us once it's plugged into the internet. Okay. So the other bit of it is that you actually once, and I hope we're going to create a Bayesian classifier just as a proof of concept, but we're not. We want other people to add pieces, but ultimately people choose what to follow, right? So if you feel that one of these systems that are plugged in is malevolent, you can unfollow it, right?
Okay, I think this is also a discussion we would like to continue, but I can see some people also pressed for time, and we still have Dimitri coming up. But I think quite a few of us would like to continue the discussion. And
sure. Actually,
some of these questions, I'm sure, are also ones that will continue as you guys start coming out with stuff in the next few. I mean, you mentioned it's a matter of months when you already be publicly sharing more.
Yeah, I think we'll see a testnet this summer. Yeah.
Yep. So then I'm sure there will be, because on the surface it looks like it goes against some of the principles of previous versions by introducing AI, and I think that's a topic that will get a lot of discussion. Yeah.
Sure.
So thanks.
Thank you.
Okay. Okay. Then. We have now Dimitri Chupryna from TAAS, Token as a Service, closing it up for our program today. And this should be particularly interesting as there's been a lot of discussion and a lot of news recently about how people can potentially profit and have instruments that are helping to invest in cryptocurrencies without actually going through the mechanics of owning them and the risks of buying and selling them. And Token as a Service has been building on Ethereum as a way to do this through tokens. And so we're very excited to have you, Dimitri, to share more about that. And with an approach that's maybe outside of the reach of the SEC in the US. Yep.
All right, thank you. I'd like to start by saying thanks for Richard and Rick for organizing such a great event. It's nice to see so many people show up on a Wednesday night to speak and hear about Bitcoin. Even my Airbnb host, Brian, is here tonight, which is exciting. I'm pretty sure he's as mind-blown as I am about some of the stuff that's been discussed today. My topic is actually much more lightweight. I'll approach blockchain not from the technological point of view, but more of discussing financial potential that blockchain markets have. Well know that blockchain tokens and cryptocurrencies have intrinsic value decided by the community that participates in it. And this will be the topic of my speech, the challenges and opportunities of blockchain markets. And so I'm a part of TAAS team. TAAS is a tokenized closed-end fund. It is designed to reduce risks and technical barriers associated with the owning and trading cryptocurrencies and tokens in the blockchain space. So I'd like to give a brief overview of the state of the markets right now. What was about $65 million in 2013 grew to be more than 9.15 billion today. And this market just continues to grow exponentially as more and more capital inflow is coming into the markets. But there's also a lot of barriers and insufficiencies that are at this current stage right now in the market, starting with the very simple technical barrier. Can you please raise your hand if you've ever had a Bitcoin wallet or have it right now? Okay, so I'm pretty sure the first time you set it up, we'll share the same frustration of going through the process, writing down the seeds and all that. Imagine that for more than 600 active cryptocurrencies that are available on the market. You don't want to keep them on an exchange because exchange have a counterparty risk of being hacked into and your money being stolen. So there's a lot of security measures that need to be thought about. For a normal, regular person, there's a lot of technical stuff that needs to be thought about, and it's a huge barrier right now. Second leg of market understanding, blockchain tokens and cryptocurrencies do not behave like regular shares or regular currencies, mainly because there's internal economics of different blockchains, starting with the basic ideas of delusion supply, for example, like with Bitcoin. There's one set of rules, there's another for Ethereum, and so on. So you have to be very cautious about understanding what drives the supply for blockchains and whether the technology is driving demand from the community. So there's funds in the space already, but the problem with them is they're not really transparent, and because there's no regulations, they're not compliant. And that drives limited investment instruments because of all that. Next slide, please. So the vision behind TAAS was to create the first transparent fund that is in the blockchain space. This is achieved with the cryptographic audit technology that I will talk about a bit later. This is a simple set of solutions that are actually very powerful, and we think that by setting this standard in the blockchain community, we're gonna see other ICOs that are coming in this space, other investment instruments pick it up and develop on top of it. So we invest in blockchain, as I discussed, and we are distributing our earnings to the token owners through Ethereum smart contracts. Our token itself is an Ethereum smart contract. It's open source. It's on Etherscan. Everybody can check it out. We're also developing a Kepler platform, which we think is a big gap right now in the blockchain investment space, because there's no real data-driven platforms and strategies to for investors to use to really understand what is going on with their portfolio. So how it works, TAAS. We are a blockchain-focused fund, and we are operating only with trusted exchanges. Of course, there's more than 100, but really those that matters are less than 5, I think. Our earnings payout, as I said, is done through Ethereum smart contracts. We share 50% of profits that we generate through smart contracts. Then 25% is reinvested back into the portfolio. So the idea was we are a closed-end fund that is closed-end fund is basically when a fund generates initial capital and then closes after the certain date or limit is set. And so the idea was to reinvest the profits that we make to grow the portfolio base over time. We have a reserve fund that is 10 to 30% of portfolio. It's hedged in Bitcoin that provides liquidity during quarterly payouts. So next slide, please. And so this is what the blockchain markets really look like right now. It's an obvious picture, but it has a lot of very important implications. Of course, we're all very much enthusiastic about Bitcoin and blockchain, but when it comes to investing, all we care about is real fiat gain. So it starts with fiat, and then the money's flowing into the Bitcoin ecosystem. I don't know if you've been following recent Bitcoin price fluctuation when it grew to 1,300 and then dropped to like about 900 or something. What happened was the money actually, some of the money flew back to fiat, of course, but we are seeing a huge altcoin bubble right now. The market is exploding because it is what started with Bitcoin went to altcoins. First, the larger cap coins like Dash, like Ethereum, like Monero, and all that. And then it's moving through the system back to small cap and back to Bitcoin. And so TAAS is focused on understanding that logic. We're doing, we have some models that are actually tracking volume in Bitcoin price fluctuation and what currencies respond to that, what don't. So this is our main focus, investing in these cyclical pattern that we have identified. We're also doing some cross-exchange arbitrage and algorithmic swing trading. Derivatives are a very small market, but we think it's going to grow. It's going to grow a lot, and this is also the point of our focus. And so this is what the market looked like in 2016. This is the simulation of one Bitcoin invested on January 1st in 100 coins, 100 the largest coins that have largest market cap. And so basically it returned 300% in Bitcoin, a bit more in USD equivalent. And in 2017, as I showed on the couple previous slides, the market has already grew again by 300%, and it just keeps on growing because we are in this very young market that attracts really big capital inflow. And so we expect these numbers to continue rising only because this is such a young market with so much potential in it. Yes, so we have selected 100 altcoins based on the market cap, so 100 largest coins in the system. 100 biggest. Yeah, 100 biggest coins, and then we did a simulation where we invested the similar share of 1 Bitcoin, so 0.01 Bitcoin in each of those coins, and this is the return that was generated. There's different ways to approaching indexes. This was the simplest way to show how explosive this market really is. And so in 2017, one of the main reasons the capital inflow in the blockchain continues is ICOs. TAAS is having an ICO ourselves. We launched 9 days ago. And there's more than 25 ICOs expected in 2017. I believe 4 or 5 are happening right now, and it just continues to move on. I think there has been about 7 or 8 already in 2017 and more to come. And so transparency is achieved with very simple but very powerful tools that we call cryptographic audit. And it all starts with the auditable exchange accounts. Basically, the way it works is we have our exchange accounts which we trade with, and many major exchanges allow view-only API keys. And basically, how it works is you go online and you see what is happening inside of our account through the view-only status. So you see our portfolio and the transaction history and everything that happened through those accounts. And then regular blockchain snapshots. The idea was to show not only the transactions in the portfolio we have right now, but also to go into the history and to make sure there was no single point where capital could be compromised. And this is achieved with regular blockchain snapshots where they're hashed onto an Ethereum blockchain twice a day. We're providing a convenient contract explorer for user friendliness to go and look at the past activity. And for those accounts that are not on the exchange, there's a way to do it through a transaction with special marker. Basically, the way it works, it tells you that accounts are indeed belong to us. Next slide, please. For those of you who are not familiar with Ethereum smart contracts, this is a very simple, very powerful idea. it's a pre-written logic in a computer code that is stored on a digital ledger, which is a blockchain. And it can be, there's many use cases for how to approach and how to use this technology. The way it works for us is we are doing automatic payments through this blockchain. So Kepler is being developed right now. It's currently at the pre-MVP stage, and the idea was to create a platform for the full investment cycle to be covered from a single point. So it is in the development right now. Most of the development is actually on the portfolio management and investment objective side. So we're analyzing data that is available on the market through exchanges right now. And we expect beta to be released by the end of 2017. We're actually expanding our team right now with more analysts working on the market research and analytics side, basically providing fundamental analytics data in terms of hash rate graphs, transactions, volume, and all of that actually supports the network and drives the network effect in the blockchain. So this is the team, 4 co-founders. Andrei Dubetsky is the co-founder of Bitcoin Foundation Ukraine. He's our MD. Just move on to the next slide. This is Andrei Zamovsky is our chief blockchain architect. He's one of the early Bitcoin pioneers, worked at Tether. Oleg Vasilenko is worked at Tether and Holy Transactions too. This is Matvey, data analyst. Alexei writes smart contracts for us, and Olga is in marketing. We also have a lot of partners and advisors. Marshall Swat is a founder of ATC Inc., the cross-exchange arbitrage that I discussed. Michael Kostash is the known VC, CEO of CrowdMentor. And Arnold Spencer is provides legal support in the United States. In terms of companies we work with, HLB is going to be doing an audit. MBSafe is doing our tech stuff. Exxon is legal. Waxman PR from New York, and Qubits for all EU residents who are interested in buying Bitcoin but still haven't done it. Qubits is the best, one of the best ways to do it. It will basically send you Bitcoin pretty much right away. Just a bit more advisors we have and partners. Sergey is from World Bank Group. David is Waxman PR. John Won has been an investment banker for more than 25 years. He's a portfolio manager in Hong Kong right now. Just more legal. Patrick and Pascal are our Swiss partners. And so in terms of roadmap, we started with an idea in October, and by the end of December, we had a white paper published. There's more than 17 pages of what I'm talking about online. Feel free to check it out. Initial coin offering started 9 days ago. We just hit $3 million. And we expect operations to begin late April, early May. So the first program payout will be about July, August. And the Kepler is expected in December, actually, not September. And so an ICO is a new wave that actually is disrupting venture capital industry right now by democratizing this whole process and allowing everybody to participate in a project. Usually the way it works is it's a way for early adopters and backers to join the project by acquiring some supply of the coin supply. So that is an ICO, initial coin offering. In terms of TAAS ICO, we're offering 100% of tokens. It is actually not so usual for ICOs, and the reason behind it really goes into the business model that we have developed, TAAS, token as a service, and a service being subscribing to and opting out of income stream that the company is generating. So being a closed-end fund, we're open for investment only during an ICO. It is only tokens that are not sold will be burned. It's just a fund distribution. You can find it all in the white paper how it works. The 100 million is the cap. Well, one was a marketing idea, but 100 100 million is 100 million is the cap that the fund can actually provide. Is a cap for a fund in this ecosystem today. We believe if it goes more than that, it cannot really generate substantial yields.
Where's your management fee?
I'm sorry?
Where's your management fee?
0%. It's only 25% profit incentive. Management fee is 0.
Okay, but then how do you make money? It's through the...
So the business model is very simple from all the earnings that the company is making. 50% is distributed via smart contracts to token owners, 25% is reinvested, and 25% of profit is covering operational and development expenses.
Okay, and that includes then your own profit.
Yeah. So 20, yeah, but there's no management fees, so only profit fee.
Somewhere in there, right? Whether it's explicit or implicit. And I'm sorry. Also, the reserve fund. Can you explain again? What
Yes, reserve fund is an idea to provide liquidity. So for an investment company to be open in the market, you may be advised to close your positions if you think they're going to be generating higher yields in the future. So reserve fund provides liquidity because every quarter we have to distribute earnings to the token owners. And the idea was to develop a reserve fund that stands for, it can fluctuate from 10 to 30% depending on the market and how we see it, to provide liquidity for the payout. So it's a simple idea that we do not need to close our positions and can have this fund that is generating passive yield.
And who owns the reserve fund?
It's a part of the general portfolio, and it's within the company. Next slide. So that's an ICO bonus system. As I described, ICO is a way for anybody to participate in a new blockchain project by acquiring a coin. ICO is live and running. We have 22 days left, and we just ran out of the second block. That was for the second 1,000 of Bitcoin. Still have plenty of room for bonuses. So just a quick summary of my talk. Blockchain space in terms of financial perspective is exploding right now. A lot of capital flowing to the system, and there are possibilities for the community to really participate not only ideologically but also financially, and TAAS has been designed to provide that opportunity from an investment perspective. It is a transparent fund achieved by cryptographic audit. There's a lot of technical stuff that you guys can check out in the white paper, how it works exactly. We are an Ethereum-based token, so the payout is done through smart contracts. And the Kepler is additional product that is in the making. We think because of the gap of no real data available for any investors or traders really to evaluate their portfolio, their risks, their performance. We think it's going to be a big block for mainstream adoption and basically big money entering the system. All right, thank you very much.
Thank you.
I saw the reserve fund is hedged in Bitcoin.
Yes.
How do you hedge? Do you go long or short on one of these markets?
Yeah, basically it means that we own 10 to 30% of our portfolio in Bitcoin.
Okay. And your payout is in what?
So because it is a smart contract that governs the process, it has to be Ethereum.
Okay, Ether.
Yeah.
Okay. And I was wondering, since you have a lot of Bitcoin and other tokens under management, you could actually issue a token representing Bitcoin. Because that's not, some people have tried this, but no credible party so far has stood up to actually issue an ERC20 token that is backed by Bitcoin holdings.
Yeah, so the token itself is the like we call it a proof of membership in a fund. It does not really try to replicate Bitcoin in any way or have any code really tied to behavior of Bitcoin. It's more of the participatory token.
It was a suggestion. So
oh yeah. I mean, sure.
And then the last question. So if you invest in the stock market, you can either choose for index funds or managed funds.
Yeah.
So you actually have a managed.
Yes.
Yes,
the fund is actively managed. We have indexes that we have developed. It is in the product. It's more coming as a full product in the Kepler platform. It is currently used and developed internally in the company, but we're opening it to the public by the end of 2017.
But if I invest in a managed fund, then I want to look at the track record of the fund managers.
I mean, yeah. So all of us have been in this space for the last 2 or 3 years, since mostly 2014. Mostly on the financial side, like we've been exploring how to really approach this market. Our tech team is, I mean, the track record is Tether Experience, and they are a very well-known company in San Francisco doing all that. And so, yeah, I mean, you can explore more about the team and the management and the advisors on the website, and there's a lot of information.
Okay, thank you.
Okay, other questions? Yeah, maybe 2 questions. One, I think the management fee question was a good one, because if you need the positive returns to pay for your operating expenses and to keep the whole platform running, then what happens when the portfolio doesn't make a positive return? And second, maybe how is the fund different from some of the ETFs that have been attempted to be launched in various jurisdictions?
So to answer the first question, yeah, if the company is not generating any money, then it's at a loss. But we'll have this 15% of the ICO that we are raising to cover the expenses of continuing the platform building and the development of TAAS. So that should cover us for some time. To answer the second question, there's surely different funds in this space. What sets us apart is the transparency that we're offering by this cryptographic audit technology. And because, of course, we're not the first investment mechanism, but all the solutions right now do not really offer an investor the tools to really go on and check out what is happening internally in the company.
And would it be regulated?
We're incorporated in Singapore, and we have been in talks with MAS. So far as we are a crypto fund, and we do not require a financial license to operate there. By developing this cryptographic audit technology, we're expecting regulation to come. That's why we want to set standards for compliance industry to follow. And I mean, so this cryptographic audit, we have it for our own ICO, but we actually realize the potential for a future wave of ICOs to come and pick it up, because right now the trust mitigation process is done with the escrow, and this is basically a solution for a community to choose people who we trust to make sure the company is indeed using the money they told they would. And cryptographic audit really removes that, because it does not need the escrow process. And I think this next wave of ICOs will pick it up and surely set the compliance standards for the future.
Okay, thanks.
Okay, I think it's been a long evening, so and I think yeah, appreciate people who stayed, because it's very interesting and also closer to really what's happening today. You guys also just have already in 9 days raised 3 million, so counting. So that's also exciting to see a great launch, and I think we'll all definitely be following to see how it goes in raising your first round. Yeah.
Thank you.
So I'll give it to Richard maybe to close the session. Yep.
Yes. So first of all, let's thank Dimitri, and also congratulations on a successful launch. Thanks to everybody who came. Thank you very, very much. Next time, please check the site. We have a couple of interesting additional Bitcoin Wednesday meetings coming up next week on the 12th and the 13th and the 14th. And otherwise, hope to see you guys next month. I believe it's the 3rd of May. And let me say thanks to Rick for hosting and being such a good session chair for us. Thanks to all of the speakers. I will do my best to name them all. Jeff Garzik from Bloq, Dimitri from the TAAS Fund, also Dominic from DFINITY, Rikya Masuda from BitFlyer, and also, very last but not least, Guy and Eyal from Bancor. Did I forget any speaker? I think that was all of them. There were, I think, very, very interesting talks that everyone brought. So thank you very much for that. And also, I'd like to thank the crew that helped put this on. First of all, our hosts from Sinatol for providing the very nice facilities, as well as the crew who've been helping to film and to live stream all of this, and also the team who's helped to produce and to put on Bitcoin Wednesday. Really want to thank all of them. Thanks also to the people who've been watching the live stream. Thanks very much. Hopefully we'll be able to be streaming more in the future. So thanks very much for watching and for sticking with us. And once again, hope to see all of you at the next Bitcoin Wednesday. Please bring your colleagues and your friends and family and spread the word so we can keep on doing this. Thanks again and have a good night.